Does anybody have any questions to begin? Danae, are you running away or going to the microphone? Okay.
All right, so Danae Carlos and SSL. So one of the things that I feel that we were missing in the start of this meeting is kind of almost setting the scene for EPIC and some of the accomplishments or the work that's been done since the last meeting of last year. I see a lot of it in some of the presentations, but I feel like we haven't really talked about the progress that we've made over the last year, and I'm trying to see if I can get a little bit of that out of this particular panel.
Okay, yeah, thank you, Danae. I think, yeah, it's hard to have all the presentations in the first day. So tomorrow there is a presentation by David Huber of EPIC talking about some of the user support capabilities that have been spun up. But until tomorrow, Enrique, maybe since you are part of EPIC, would you like to take that on? There is a button there you need to press when you want to speak. So then the light should come on.
Can you hear me? Okay. I think that in this situation, perhaps the question it's a multifaceted question, right? So you have different parts of EPIC. So you have the contractor, you have the program. So I'd like actually to invite, this is an open discussion. It's informal. Anybody can stand up, anybody can make questions, anybody can participate. And since we have Maui Huang, our program manager here, I think that she would be in a better position to provide that answer. So I'd like to invite Maui, if you'd like to get one of the microphones and provide that. And then again, maybe it could be an opportunity for somebody from the EPIC contract as well. I see Kevin is here to provide an overview and answer that question. Do you think that would be satisfactory for you, Danae? Okay, so if Maui, if you feel comfortable with that, I would like to invite you to provide some feedback to Danae.
So, thanks, Danae, for putting me on the spot. I wasn't prepared to speak to it, but I want to just reiterate some points that Dorothy provided in her opening remarks on Monday. Those are at very high level. I will just summarize them in three high-level items. One is building the community. So if you look at the EPIC strategic implementation plan, which we haven't released, sorry, we're actually going to focus on three high-level activities. One is to build the community. This workshop itself is a community building exercise. We also try to reach out to working with UFS steering committee as well as NOAA modeling team to make sure we understand all the stakeholder requirements and inputs and making sure that we find out a way to implement them. It's not that easy to consolidate all the inputs, but we are making progress, right? So that's one of the aspects we have been focusing on in the past year. The second thing is that in the past year, we are trying to focus more on the short-range weather application, working very closely with DTC and GSL. And we actually released two SRW versions. One is SRW 2.0, another one is SRW 2.1. And as well as focusing on working with the land modeling working group to release a land DA system, which some of you might have participated in our earlier training sessions. So this, but I agree with some of the panelists because EPIC is largely engineering program from my perspective, in addition to some of the community building activities. we actually have some difficulties in clearly articulate exactly what those capability work we need to do from our end, working closely with you to clarify the engineering the scientific purpose of the engineering development. Right, so that's the second thing. And actually, when we started supporting both land DA and short-range weather applications, the intention is actually to make sure we have an end-to-end system that can be released to the community, not only including the infrastructure, including how to run it, providing the tutorials, as well as to release it with data set and use cases so that people know how to replicate it. I would welcome you to the hierarchical system development presentation that Mike Hack will give later this week to better understand that approach. And as Nija mentioned, we worked closely with DTC to develop that concept, but that needs some additional thinking and support in the future. And the third activity is actually to, let me think. To have a way to make sure we have a way to demonstrate how we bring in innovation into UFS. And that should be built on infrastructure, right? So if we don't have the sound infrastructure, it will be hard for us to demonstrate that point. So again, we worked closely with the short-range weather application team and DTC to building some of the matrix, the forecast scale matrix, into the SRW application as well as the land DA system. That one was recently delivered to the program office just 1 week ago. So a lot of you have never seen that, but the purpose there is that in the end, we want to provide a dashboard. So if you grab a Epic configuration, you should be able to grab a use case and then look at how much improvement you could have by changing a physics parameterization or changing some of the DA configurations in the future. The DA component is yet to be discussed. But those are the three components we have been focusing on in the last year. I'm sorry I don't have any slides to show you, but I would welcome my team to provide additional inputs if they are willing to.
Thank you, Maui, and I hope I still have my job after putting you on the spot. And I have more people that I'd like to put on the spot here, but I'll leave that for a little bit later. I'd like to invite, before actually your question, if you don't mind, just for continuity of this topic, to have Kevin step up and just provide some additional comments from the Epic contractor side.
Sure. Yeah, thanks for the question. I'll be pretty brief. I think Maui pretty much hit all the areas. But to answer your question, I think the one thing that we've really worked on is transparency. I think that's really the last item she hit with the community dashboard is how do we really make this easy to see so that as you make changes, as things go through pipelines and all the infrastructure that you can't see behind the scenes, what does it really look like to be transparent to the community? And that's kind of what we spent a lot of time on working on lately is really to hit that home so that question doesn't have to be asked in the future. Everything's right out there in the open. To include the biggest question we get asked is at a lot of our code fests and hackathons is how do I do this on my own? So some of the team members have ways that they create, you can create all the infrastructure on any of the 3 cloud service providers in about 7 lines of code. So that's a really transparent way that anybody can take these applications on their own and build them out pretty easily. So thanks.
All right. Thank you very much, Kevin. So we'll go to a question, Phil Pajan, and then we'll check the online.
Thanks, Ligia. Phil Pajan from NOAA's Physical Science Laboratory. And there's all this talk about the UFS, the Unified Forecast System, and it seems like a lot of times it's just viewed as the model, and a forecast system is more than just the model. There's data simulation, there's product generation, all that. And Luke, you touched on this in your talk about the data simulation. That's not a community-developed model. It's behind a firewall, and that's, I think, a big hindrance on building a unified forecast system. And I want to get your perspective, and then put Tom on the spot on what are the barriers to making that a community system.
Yeah, I can touch on some of that and kind of go back to Danae's comment on the progress of EPIC. I think the progress of EPIC has been very beneficial, not so much to us because we are extremely, and I will speak for the people that work with me, not myself, extremely advanced users of the UFS infrastructure. We don't need a graduate student test. We don't need an example of how to run on AWS. We've been doing it for decades collectively. So we're highly advanced users. We can get around these barriers. It just takes time. So we have to do additional development. We have to build things that don't exist or build things that are behind our firewall that we don't have access to. So we have a lot of really talented people that can just build it. So really the hindrance just adds time. There's nothing that's unknown for us. We just have to build it if it's not available to us, or if we don't have the documentation, we have to just figure it out. But yeah, so I don't know if that kind of answered the question on EPIC progress. And in addition to the EPIC progress, we have a lot of some of our scientists and engineers are actually on the EPIC contract, working under Raytheon, contributing our kind of expertise back to the EPIC program. So I think once EPIC becomes more mature to the point that we can really dynamically use the software, the code, and contribute back, I think that's when somebody like Tomorrow.io can actually really benefit from EPIC, and the overall community can benefit from us. But it's too early, I think, for that level. Did I adequately answer your question? I feel like I kind of answered two and gave you only half partial answer.
Not fully, but it was sort of getting your perspective, and like Shih-Wei, I'd like to hear your perspective on the DA, because that is, it is behind a firewall, and you don't have full access to it. And is that a hindrance for your work?
Right. So so far, because we have been working as a developer data simulation, so that means we already have who are developing the simulation itself. So talking about GSI, we are not having that problem at all. So I guess you're talking about JEDI, Phil. Is that what you're asking for?
Yeah, it's because JEDI, so the UFS is this focus on being a community model, and JEDI doesn't have that charge. And I'm saying, is that a problem?
Yeah, we just started use JEDI for our work. I think one thing that related to what you're talking about, there seems to be a public version versus like an internal development version. I think for public version, we can access very well. An internal developer version, we do have to ask people, that's, to close developer to have access. And yeah, I think having direct access to this system, transparency and direct access will be very helpful for everybody to be able to access the system and put the efforts on the development and translate, get our own development into the system. Yeah.
So,
All right, thank you, Shih-Wei. We're going to give the opportunity to Tom Alinier to say a few words.
Thank you. I'd like to just to correct the idea that the DA system is behind. Our code is open source. It's actually available to the community. We have more than 1 million lines of code available to the community. We did 5 public releases this year with UFS atmosphere, aerosols, land, marine. And that's all available online on our website, jcsda.org. So all the code is available. And on top of these releases that are done quarterly, you have direct access to the latest version of the develop within seconds. So basically, you have access to all the JEDI code for these releases in real time. So the piece that's still behind internal is actually the agile boards, and this is actually a discussion we're having with our board, multi-partner boards, with multi-agency boards. So that's the part that's actually internal.
You said you are having discussions on making that available, not internal. Oh, great. Good.
All right, thank you, Tom. Let's see, is there any question online? No, okay, so Julian, go ahead.
Hello. I'm short, gotta adjust. So I have a lot of thoughts about all of this. But I think first to address Danae's question about some of the new developments that have been happening with Epic in the past year, 6 months, I will say I work on the AUS team, which is the Advanced User Support team. And although things were a bit slow to get started, we're really trying to work on transparency in terms of providing user support in a timely fashion. And we're using GitHub discussions primarily for that. So if you or your students or anyone else really is working with UFS repositories that Epic manages or supports, you can post in the discussions. So I will say, to be clear, that's the SRW, UPP, LandDA, and the UFS weather model. So for those four, we have more support. For other repositories, you can post on UFS community discussions, and we will try and get you the support. But that, for a while, I think wasn't getting enough attention, and now we're really putting a focus there. So I would highly encourage you to use that functionality. We're also trying to, we've added Epic support requested labels for issues. If you're not able to add labels yourself on GitHub, you can request that when you create an issue. So you'd create an issue if there's a feature that you want to see or that your students want to see. We can't guarantee it'll happen right away, but we can put it in the queue and we can forward it to the right people. And I think that's been a huge issue with UFS is like, I mean, I'm hearing so many of the same issues from everyone in academia, and it sounds like nobody really knows quite how to get those into the queue so that they can get some attention. So I also highly encourage creating issues. And then I guess because it seems like there are some shared issues, I'm wondering, you know, there's like the system architecture working group. There's a bunch of working groups. Is there a working group for academics who are in climate modeling of any kind? Because I feel like it would be good for us to be in touch with some sort of organized group of academics who are working on UFS-related topics, so that we can figure out what needs prioritizing and how we can help better. There's my question.
Yeah, that was a great comment and question. So thank you, Julian. I think at some point it might be worth it to do a demo during this workshop about how to post on GitHub discussions, because while we may think it's trivial, people just don't know where it is. So,
Yeah.
and I was looking in the SRW app user's guide, and I think it's like several pages in when we get to the information of how to get help. So I think we're gonna have to move that
I'm
up.
also reorganizing the user's
But
guide.
I'm gonna pass it to the panelists, but I thought maybe I could start with Shih-Wei. So Shih-Wei, you are one of the co-leads of the UFS release team. And so you kind of represent the community, you know, the group that Julian's talking about in terms of how releases are used. So can you talk a little bit about how can we collect this input? How can we be more in touch with the academic community? And, you know, Sarah, Luke can also help us with that.
Just have a survey like what I did and you did, and send it out and engage them to provide inputs. I think that will be one of the efficient ways. Yeah, I felt like that's very efficient. So that's what I did with my group. You hear them directly.
I guess one concern is we don't necessarily know who to send the surveys out to. You know, now that I'm seeing you all here, I know that you are professors that we could be in touch with, but we don't necessarily know the full extent. So I'm not sure. It seems like there's sort of a communication gap and knowledge gap there. Because I agree, the surveys would be fantastic.
But I think one approach is I think you want to find a mechanism to keep track who is actually using the UFS, right? And I think there should be a way of doing that, right? I'm not sure GitHub download have a functionality like that to allow you to track the users. Once you have that database for users, I think you should be able to send your survey to those people and ask for inputs or feedbacks.
Okay, let's see if there's anybody else on the panel that wants to comment.
Yeah, so I guess the verification workshop there's a workshop couple years twice, and then you know you have initially reached a certain group, but for example, there's one area is on air quality, so we specifically reach out to end user. So sometimes you have to build stuff on somewhere from wherever you know, but you know there's a gap there, right? So for verification metrics workshop, then I specifically reach out to air quality focus people, ask them to provide feedback. So you need to almost proactive reach out to those potential end user. And also I think UFS a working group, but if the working group is more with people already work on development and already funded by UFS, it's difficult to grow the community. So then you have to open up, so to have new idea. So then working group cannot be only those people already ongoing.
Okay. All right. So we move on. Neil, are you online or fine? And do you probably have your own questions you want to pose, but if you also want to speak to Danae's question about the progress of EPIC, that would be great.
Well, I was actually going to address what was just being talked about, because I think this is actually really timely. So I did want to point out that Alekia has been working on this as a La Penta intern. But we just, so we being UCAR CPAS, just hired a person a couple days ago. They haven't started yet. She was here yesterday and last night. Her name's Allison Gregory, and she's going to be working with me, specifically doing outreach coordination to mostly the academic stakeholders. So what we're going to be doing is trying to get the input from the users of what they want to see in the UFS. So whether it's doing surveys, and her background is a mix of atmospheric science and social science. And I think she's going to be really awesome at this. So this, to me, getting this feedback is essential, because I hear this a lot from people that do the graduate student test. They're like, this is really cool, I could run the entire model, but really for the purposes of a teaching tool, simplified, idealized cases are way more useful. And so for what you can get with CSM, I'd love to see that as part of a way to engage the academic sector. But you know, really when EPIC first was initiated, the point was taking the production code and putting it out into the public. And no one at NCO is using that kind of stuff in their model, because they have a total different mission. But it needs to be in there if we're going to engage the full community. So this information is super important. I just wanted to let everyone know that we're aware of it. We've hired a person. Their full-time job is basically going to be reaching out to the universities and getting input and feedback on what you want to see in the next releases, as far as how you want to use it both as a research tool and a teaching tool.
All right, well, thank you. Go ahead, Danae.
Yeah, so I just want to piggyback a little bit on Phil's question, and you know, when I listen to some of the speakers and they talk about using JEDI, I really don't know what that really means exactly, you know, because at some level we've been talking about using the use of JEDI as the next generation DA system for several years, but I feel like we're all over the place as it pertains to the use of the actual system, you know. And so I'm just kind of wondering, you know, and Luke, you talked about you have the talented people that can kind of get around some of the barriers with regards to some of the modeling capabilities that are out there, but everybody doesn't have that. And you know, as a community, how can we be more transparent about where we are in our kind of research and development process, the R2O process at the kind of end of the day? Because that to me is where the community can actually benefit.
Okay, Luke?
Right, so what does it mean for us to use JEDI? It's fundamentally the data assimilation system that we use to ingest observations in real time. We're not doing research, we're doing operational forecasting. So It's the observation, quality control, data ingest, real-time data ingest, forward operators, that are basically translating the observations into the model state, the entire workflow. There's some workflow elements that come with JEDI that we are using, but it's not robust enough for us to be cloud agnostic and things like that. So we take all of the pieces from JEDI that we need, forward operators, just the fundamental pieces of data assimilation, background error covariance that we're generating, the spectral coefficient generator for our passive sounders. We're using a lot of those components. Some of those aren't fully released. So some of the development that's behind what we've been calling a firewall, we have to get around that, those elements as well. So really it's just making the entire data assimilation system operational. We use what's available, we build what's not available, and we operationalize.
Sarah?
So, Dina, I guess Tom can answer a lot of your questions, but at least the JEDI have a lot of different elements. So for us, Shih-Wei and I, we have a project because JEDI is a DA system, really know how to map observation data to the model data to observation space. So we actually couple that with Map+, which is for verification purpose. So in addition to be a DA system, there's a lot of very nice science element can be used for different application.
So Luke, you just said you guys are operational with JEDI.
Well,
I think you're the first person I've ever heard say that.
We are building an operational system with JEDI, and we're doing it because we have utmost trust in Tom's team that it's going to become the next generation data assimilation system in the US and UK Met Office. We don't want to invest time in working on a legacy system that's GSI if this is going to become the next generation. So we made the choice, assuming that JEDI will become operational in the community, but we may be the first to truly operationalize it, I guess. But yeah, maybe it's ambitious.
I wonder who else has it operational. Any other organization in here?
So,
other than JCSDA?
So I get your point. There's a need for more communication on the status and the development that's happening, and I'll invite you to my presentation in the system architecture parallel session where I'll actually show a high-level summary of this. 2 months ago, we also had a joint center workshop. If you want to dive in, if the high-level status is not enough, there's a lot more. So we had, dozens of presentations about JEDI developments, about JEDI status, about the transition plans from all the partner agencies and line offices in NOAA. So there's a lot of material. The recordings are available. The presentations are available. I can point you to that, and I invite everyone who is interested to come to me if you need.
I only asked that question because everybody, it feels like we're waiting. So if we shouldn't be waiting, then why we're doing something wrong.
So we have hundreds of people in NOAA and NASA and Air Force and Navy and Met Office who are not waiting, who are actively working on developing the best system in the world.
All right. So we'll have to come to Tom's talk and learn more about this. Meanwhile, we'll go for a question from online.
Yeah, we're going to sidetrack from JEDI for a second, but this question is from Stuart Young. How significant is runtime prediction and compute environment or optimization for different data sets and algorithms for research and production?
All right. Anybody want to raise their hand? I mean, I think there was some discussion before about the code being, there being some barriers to install outside of the NOAA Tier 1 platform. Any comment on that?
I mentioned that yesterday. Shih-Wei also mentioned for us to put on our clusters is some issue. But beyond that, for research application, a lot of times it's platform dependent. And it will be unrealistic for me to expect AP tell us how to run our machine. So that means we need to work with our university IT people. But guidance about what is needed and what's the minimum requirement, what's nice to have, that kind of information can help us to get started. So then, but a lot of times the optimized code, whatever is really local because each machine is different and only the user really know. So that's my point. I don't know, Shih-Wei, things to add?
Yeah, I just want to add one thing is Fridays we will have Christian's had his presentation about how he run the UFS code, and he's running on Cheyenne, which is supported by the UFS community, but I think he still need to figure out how to specify the layout for the UFS code and the work collector time to optimize his code running on the Cheyenne. So it will become the same issue with the university cluster, because like our cluster, we actually have an Intel compiler, but that's the 2015 version, pretty old. So we actually cannot install the updated library for the UFS. So that kind of support we need to work through with our ITs. So I think that basically that's the difficulties we face on our university clusters. Yeah.
All right, I'm going to keep moving. Louisa?
Can I respond to that last question too?
I was going to change the topic slightly. So I hear everything everybody wants and needs in order to engage with UFS. And we're trying to really support a really broad range of community. And so I just wanted to say that community. So while Epic can provide a lot of capabilities, they've got talented software engineers and all that kind of stuff, I think other community models have relied on community development going back in. And I think about some of the needs for more idealized capabilities, and I think about HWARF when DTC was supporting that. We actually had graduate students who developed some idealized capabilities, and DTC supported those getting back into the repository. So as we advance as a community, if everybody can provide what they're developing for their release, for their research back into the repositories and be able to get those things supported out to the community, then we're all going to be able to grow and advance a lot more quickly instead of maybe totally relying on one group to do everything, because we're going to be waiting a long time if we're relying on one group to do everything. So just a thought to think about from that perspective.
Yeah, thank you, Louisa. I think this is really important. I think there's not going to be like a one system push button GUI that's going to execute all the, all possible idealized cases. So perhaps Epic can play a role into being, a distributor, documenter, and supporter, but there has to be contributions coming. So, Christiane.
Yeah, good point, Luisa. And I briefly mentioned that we have a couple of examples already in DTC, with the physics, for the single column physics model that's based on the UFS. And then we have these examples from GFDL, the solo model, and we have the CSM examples. So I think we do need a facilitator at this point, because we already have pieces, and I think we're all happy to contribute, but we don't quite know how. I think that's really the point that we should tackle.
I could quickly comment on that as well. I think there's a lot of components that you can, I don't understand this thing, lights on, I'll just leave it alone, that you can contribute. Workflow elements, like research packages where it does, some certain set of research on a use case or something like that. You can contribute that to just a general repository. But contributing back to the operational code, or what I imagine is if we try to contribute model physics contributions back, we're going to have branch nightmare. We're going to have all these branches from different organizations, and then NOAA's going to be left with, EMC's going to be left with, well, what's the operational branch, and how do we merge those contributions in? But all the peripheral elements, workflows and validation and stuff like that, I could see just a pool like NCAR does for WRF, like WRF tool. It's a bunch of shell scripts and examples on how to do workflows and do some simple experiments and validation. I think that could be something we can all contribute to right now, but it has to be like a separate bucket of tools versus like the actual main branch, because we're going to have branch nightmare if we allow the community to start contributing. I just don't know how that, that's maybe for Neil to think about or comment on how to handle branch nightmare once we get community contributions back on the core science.
All right, thank you. Yeah, Sarah Lou?
I guess in terms of contribute back, I'd like to raise a potential issue could be the code was designed for research and operation, and there's certain operational constraint that could potentially cause a barrier. For example, we had an ongoing project to do land surface evaluation, and then we want to implement some prognostic process level diagnosis in the model. So the key is if we want to put a post-processing, and if that's a new field, it's not defined group 2 table, then there will be practical difficulty there now. And then we have project work on Make Plus, and then student, if they do certain Python, certain module may not be allowed by NCO, then will be also potential issue. So when you want to contribute, and there's some kind of information about, well, there's certain thing you had no chance, let us know so we can avoid. Yeah. So.
Okay, well, thank you. Hendrik, you're next.
Since the original question had embedded in that something about efficiency and runtime and what the difference was for operations and for research. Well, our operations machine at the end of life cycle, and actually pretty quick in there, are used at the 80 or 90% level of capacity. And so if you have something new that you want to put into operation that's 10% more expensive than was planned for, well, tough luck, it's not going to get in. We don't have a big enough machine. On research, of course, there's a lot more play there, but as a researcher, if you have a code that's twice as fast, you can do the research for half the cost of compute, or you can do twice as much runs. What would you like? And so, having said that, if you were lucky enough to be coding on supercomputers in the late 1990s, the Cray C90s, our operational codes could get anywhere between 30 to 60% of the peak performance of the CPUs. Some of our codes were running more than 50% of peak performance. In their new data center in Italy, the European Center is expecting and apparently going to accept 2.5% of the nominal peak performance of the CPUs. So slowly but surely, people who have worked for a long time in this field have gone from really using our CPUs to using only a really small fraction from it. Now, I'm not saying that we can go back to 50, 60%, because there are reasons why our type of problem doesn't scale very well on the new CPUs, but having that small a fraction of a CPU that you use, you actually have runway to perhaps make the code 2 or 3 times as efficient. And from an operational perspective, if we buy, say, this is a fake number, but if you say I spent the 25 million a year on computing, I could spend $5 or $10 million on just code optimization. If I get my code twice as expensive, I get back 25 million a year in terms of not buying compute anymore. And so this is really a unique time that, since we are all working with the same code, more with the same codes and the same infrastructure, that if we can figure out a way of investing in making these codes portable and a little bit more efficient, it's worthwhile to put some real money in there, and the payback for everybody is going to be incredible.
So Hendrik, before you actually leave, I think that Luke, he touched on a point that I think is very important, like kind of like coming back to the focus of the panel, which is, how to make the UFS more usable for a bunch of people in the community. And he mentioned the idea of branching nightmare. And I know, as myself, I was code manager for the WaveWatch 3 model. We had substantial contribution from the community, and we managed to avoid branching nightmare. Of course, the WaveWatch 3 model is a much simpler model compared to the UFS system as a whole. But I wanted to ask you specifically, because I think it's so fundamental. One of the big payouts for community wanting to contribute to code is to see their contributions making their way to operations. And reversely, having a functional flow of contributions from the community is really an open door to innovations, right? So that's where perhaps the more radical innovations may come from, may not. So I wanted to ask you, going back to this idea of branching nightmare, and since Luke also mentioned Neil in that, what are your thoughts, just briefly? Is that something that concerns you? Do you have in mind a way to avoid that from happening?
No, yes, and what was the other one? So, yeah, wave modeling, the model is not simple, but the community is smaller. And so, smaller community, less branches. And so, but you have to look at it from both sides. Wave model has about 6,000 users, but about 20 or so real contributors. So it's a small group, and so I have experience with that. I used that to sell the UFS over the years, but I'll be first to say that I don't know if I have economy of scale here. I don't know if that still will work if I have a much bigger community. The biggest issue that we found, and that's Arun and that's Enrique and a few others that have worked on the wave model for many years, it is, it is a culture problem. Because it is a problem where you have to get the people to do the right way of working with it. So having branches that are about one topic, not about a person or an organization, keeping these things, well, I'll keep it short. Things like Git flow. What I've seen, this is a culture problem, at least in the wave model, more than anything else, because everybody, including Enrique, including Arun, started off with saying, I don't want to do all the extra work. And everybody in this community, every last person, including the top scientists in Europe, were going, once they were going with Git flow and doing clean working on the branches, keeping them up to date, merging them back when you needed to, everybody said, oh man, I should have done this way earlier. And so I don't know if my experience from the wave model will translate to the bigger scale, but I do know it's a culture issue that gets in the way first. If we can get over the culture issue, we'll see whether it works for the bigger scale.
Thank you so much, Henrik. You definitely have a lot of experience with that wave watch, and that's been very successful. We only have 8 minutes to go, so we're going to go to Natalie and then a question online.
Hi, my question is to the academic community. For now, I know many of the academic community do use like shared systems such as Orion, and spread it to a wider community may be dependent on the installation of software dependencies. That's another hell. So I wonder if wider use of containers might solve this problem. Because most of the HPC systems, if not all, they are Unix, Linux based, and this is something we may put more efforts to in order to make it available to
Okay. All right, so
users.
is there one of the panelists from the academic community that want to take that on? Christiane?
Yeah, I think that's a good idea. And I think we need a little bit more education in the academic community, how to use containers, how to work with them. I think that's a barrier. It's not the idea. I think the idea of containers is making a lot of progress. Also, I hear that the move to the spec library management will actually do its wonders in the near future. So I think things are improving on that side. But I think you're right. This is one of the biggest barriers, and it was mentioned also by the other panelists that if the model isn't portable, we are kind of lost a little bit because our university servers will not support it. I think I got around that a little bit with Cheyenne. I do see that problem though for the academic community on Cheyenne, which is the NCAR system, that we are not able to apply for computing resources for the UFS unless we are NSF funded, and that's probably not quite the case yet. So that's a barrier. Also, if we want to go to maybe Frontera or Access Systems, these are kind of the widely available clusters, we probably need to get more help from the UFS community or EPIC community to get the libraries installed. I hope there's progress, but in the near term, and containers are a good idea forward. Yeah.
And I just want to add one comment. My personal experience with our cluster again. So using container, I can install and compile the UFS, but the requirement for in the slide or the tutorial slides said we need a Locata workflow and then slurry system to do the job management. So for our cluster, we have the slurry system, but we don't have Locata. So I try to install Locata, but then Locata needs a Ruby as a library, but our Ruby is outdated. So I cannot install Locata. So that becomes some other issues exposed. But I mean, I know that on the documentation, there's some, we can go around the Locata-based workflow, but we need to manually to execute the shell scripts, but that's not recommended by the tutorial slides. So that's another issue I faced during using the container on our cluster.
Thank you so much, Shih-Wei. We're going to go to a question online.
Yeah, this question is from John Potter-Joy. In response to previous questions, does the committee feel that more support is needed to accelerate the transfer of DA science from academia into JEDI? For example, the DTC used to provide a level of developer support for GSI.
Okay, thank you for that question. So Shih-Wei, maybe you want to start us?
Yeah, I do. Having more support is actually one of the wish lists actually supplied by the students and society in our group. So I think it is critical to have sufficient support from wherever EPIC or JCSDA or others, as we all trying now migrate to JEDI and to do the actual data submission research development. I think this support will be critical. I think in my talk, I also outlined how we're gonna establish an effective mechanism for effective support. You may actually have various questions, some of just from like earlier users, beginners, and some actually may be coming from experienced data submission developer, but they are, when they do development, they have questions on the source code, for example, for a particular solver, and this is a deeper question. So I think we should think about what we can do to support these different level of questions, and who is responsible for supporting what kind of questions. I think, I think there's something we should talk about in this workshop.
Thank you, Shih-Wei. In the interest of time, so we have three minutes left. I'll give a question to Christina. We'll get some answer, and Neil, if you have some closing words, we'll do that.
A comment that Hendrik made there, he was talking about it being a cultural problem for a branching nightmare to happen. I totally agree with that. And I think that cultural problem has been born out of a little bit of distrust of code coming into a code base that is meant to be operational at NCO, and all of the reliability that requires and the timing and all of that. And I think one way that we can start to both apply the Git flow pattern that he was talking about and also regain some of that trust is through really robust testing. And that's one space that we're starting to get into now that I think we really can use both on the trust side of this cultural issue to make sure that we're only accepting the best code into our code bases, but also it's a documentation of the code. We don't want to forget that tests give us examples of how to run. So in short range weather, for example, we have about 80 workflow end-to-end configurations that we test a subset of, but that's 80 different examples of configuration files that you can use for a variety of different purposes that we want to make sure work every time we accept a new code to the base. So those are your examples of how to change different physics, how to change different domains, and how to run an ensemble in a variety of different ways. So I don't want us to forget about the testing frameworks that we're incorporating into these systems as both documentation, examples, and that sort of thing, but as well as building that trust in the community in the code base. Thanks.
I just have a 30-second comment on top of that. That was exactly the mechanism that WaveWatch 3 used to build trust. So one of the first things that Hendrik did when way back, like, maybe 50, 60 years ago, when he was developing WaveWatch 3 with us, was to write a matrix, which we called Hendrik's matrix or something like that maybe I can't repeat here. And it would run all the regression tests available for running WaveWatch 3. And it was made so easy for any user or developer to, just release that thing, leave it running overnight. It built the trust. and it did change culture. So, I think we're on the same page, and I'll pass it on to Neil.
Yeah, thank you, Enrique. That guy says he's going to turn the lights off on us here anytime. So go ahead, Neil.
I'll keep it short. So I just wanted to bring up the fact that while we're talking about these needs and wants, that NOAA or any other government agency is not going to do anything without congressional authorization and appropriated money to pay for it. And so this message is actually mostly for the academic folks, but probably industry too. The time right now is really important because the Weather Act reauthorization, so the original Weather Act of 2017 is going to be, the reauthorization is going to get introduced this year. And it's usually every 5 years. So if you haven't, and I know there's been some drafts floating around, someone posted it on a map listserv at one point. If you haven't gotten your comments, requests, needs, and wants in to your members, you're about to miss the boat. And it won't come up again until probably 2030. And so it's really, really important. If your needs and wants are in there and you like what the language in the draft bill has to say, then have your member publicly support it, because we need to get this passed by both houses and signed by the president, because there's a lot of authorization in there followed by appropriations that's going to fund a lot of this stuff. Otherwise, it's either an unfunded mandate or just a hopeless wish.
All right. Thank you so much, Neil. So on that note, we're going to thank our panelists. Discussion, and we're going to the break now.
Okay. Should I go out there? Hi, everyone. So just start gradually making your way back into the sessions. We'll be beginning in a couple of minutes.